Okay, can everybody see my slides here?
Yes, we can. We can see it.
Okay, excellent. Yeah, and we'll just mute that mic because yeah, I'm getting a lot of feedback. So, thank you so much for inviting me. Thanks to Istanbul University, the Faculty of Communication, and the Research Council there. My name's Andrew Iliadis. I'm a professor in the Department of Media Studies and Production at Klein College of Media and Communication at Temple University. Um, I'm going to talk about my book, Semantic Media, and I'm going to discuss it in the context of disinformation and misinformation. So this is the book. It came out last year with Polity Press, and I'm going to take you through some quick examples of what I mean by semantic media, talk a little bit about semantic technologies, and what I want to do is take you through three really brief case studies that I describe in the book. And at the end, I'll kind of link all of this to disinformation, misinformation practices to see how this is all related. So most of us probably know when we search for things on Google now, you can ask questions like, is the Earth flat? And Google will give you an answer, such as, no, the Earth is roughly a sphere. If you ask Google when Aristotle was born, it will tell you 384 BC. You can see there's no reference or link to a particular website here. It's just giving you the fact. We can switch platforms and look at Microsoft's Bing search engine. And if you ask about Russian scientists, you will get a list of popular scientists from Russia. You've got the dates there. And again, no links to a website. This is Microsoft coming up with their own carousel and list of what they think are popular scientists. In another way, you can search for things to do in Philadelphia, and all of a sudden, Bing's search engine will give you a list, a sort of a taxonomy of all of these things that you can do in Philadelphia, things to do, weather, events, and then you can even sort them by subsections like architecture, outdoors, etc. And it will kind of populate all of this information about the city, and you don't even have to visit a particular website because all of the information is neatly presented to you. It's almost like Bing has its own micro blog about the city of Philadelphia. The last one I want to show you is related to where I'm from originally, Toronto, Canada. If you search for Toronto on Google, in the knowledge panel, which are these little menus on the right, you see that there's a summary of Toronto written there, nice little paragraph describing it. And you'll notice that it says at the end that it's written by Google. It's not actually coming from Wikipedia, which is what most of us might be used to. So Google is giving us information authored by Google itself about the city of Toronto. So these kinds of facts, right? This kind of information that's being shared on search engine results pages about facts are also shared on virtual assistants. Those of us who've used them know that we sometimes get facts and information that's not actually linked or referenced to a specific source, right? Siri doesn't always say, as according to Wikipedia or whatever source. Sometimes you just get the facts themselves. And so this is what I want to talk about. I want to talk about how do these facts appear in media products like search engines and virtual assistants, and where do these facts come from? And more importantly, are they accurate and can they be manipulated? So I'm not going to hide the definition. I'll just tell you right from the top that I consider semantic media as technologies that orchestrate and directly convey facts about things directly in products rather than leading people to sources. There's a focus with semantic media on concepts rather than keywords. So this would be something like the idea of Philadelphia instead of searching for the keyword Philadelphia on a bunch of web pages. Semantic media is all about identifying and describing entities and actions for interacting with those entities. If you think about that, that Google, or excuse me, the Microsoft Bing search engine with all of the little action buttons that you can use for Philadelphia. And it's all about intuitive search results, providing people with the most relevant facts
Dr.
based on
Iliadis,
context. Okay, a little hiccup there. So a lot of this, talking about semantic media, a lot of this stems from changes in search that have occurred over the last 10-year period. Most searches done today are considered zero-click searches, meaning people find what they need with a single search and don't navigate to other sources, right? So a lot of folks, and we've all probably done this ourselves, will search for something on Google, and I'm getting some feedback again. I'm sorry, whoever's not muted. It might be Meltem's iPhone, I think. All right. So most searches are zero click. People find what they need on a search engine results page without clicking through to websites anymore. Google has released white papers describing how they try to provide high-level facts about people and issues to users with contextual information. Because Google knows that a lot of the time we want quick facts. We don't need to visit websites. And there have been studies that show that 50% of people very frequently or often make important life decisions based on the types of Google information that are presented in those knowledge panels and menus. And roughly 95% of people find them trustworthy. Okay. And so Google, we know that their approach to search has changed. The former senior vice president of engineering at Google once said the perfect search engine should understand exactly what you mean, right? Not necessarily searching for keywords to find different websites, but to really understand the context of your question and give you a direct answer. So the book is based on a long history of the politics of search and search engines. I won't go through all of these, but some texts that I found inspiration in heavily were texts like Halavey's Search Engine Society, Noble's Algorithms of Oppression. And there are more current studies that address these issues. Heather Ford's Writing the Revolution, Luciano Floridi's Semantic Capital, and other texts. So many texts talking about the politics of search engines and why semantics might be relevant to that. So let me talk to you briefly about semantics, right? It's a term that I think some of us aren't familiar with, especially in a technical setting. So when I talk about semantics, I'm talking about a very specific project that started roughly in the year 2001 by Sir Tim Berners-Lee, most of us know the creator of the World Wide Web. In 2001, Berners-Lee and authors Hendler and Lassila released a cover story in Scientific American talking about a new project, a new initiative called the Semantic Web, which they saw as a new form of web content that is meaningful to computers, that will unleash a revolution of new possibilities. So what did they mean by the semantic web? Well, Berners-Lee, if you look at the book that he released called Weaving the Web, the original design and ultimate destiny of the World Wide Web, he talks a lot about metadata and about semantics and what his vision was for the semantic web. Some of you might know that he also founded the World Wide Web Consortium, which is basically a web standards body that releases standards, code, serializations that everyone should use to develop the web. And early on in that book, one of the things that Berners-Lee says is that the first form of semantic data on the web was metadata, right? Using metadata to describe other bits of data that can then be shared with each other, with different users, because we've labeled it using a similarly structured system. So I'm not going to take you through the technical details of the semantic web and what the World Wide Web Consortium does, but basically they produce the metadata and the languages that can be used to affix metadata to data on the web so that it can be shared. Semantic web has gone by other names throughout history. It's been called linked data. And today's popular term is knowledge graphs, but I'll get to that in a second. But basically, it's about affixing metadata to your data so that it can be shared and interpreted by machines in different ways. That project is a little old. If you ask some people about the semantic web, you don't hear about it a lot today. And in fact, over the years, many people have described how the semantic web was a failed project. So this is one of the original schematics or designs for the semantic web, showing you how an individual like Bob can have an interest in something like the Mona Lisa, which was created by Leonardo da Vinci, and that Bob was born on a certain day. All of these relationships can be identified using semantic metadata on the web, and that was part of the semantic web's project. But as you go through the history here, we see many examples of people who were wondering kind of whatever happened to the semantic web. Another one here saying, is the semantic web dead? Another one, is the semantic web really dead? And another one here, rest in peace, the semantic web, right? It's this considered this failed project. And one of the things I talk about in the book is how the semantic web never really died. It actually just went to work for Google. It became a technology that most everyday web users no longer used. And that was part of the original vision of the semantic web, was that we would all tag our data and share it with each other. That never really came to fruition. And actually, Google started using these technologies in search. We know because if we look at patents that Google releases, for example, this one from 2013, we can see that it's specifying entities such as George Washington and facts about that person, such as George Washington is a person, or that he assumed office on a particular day. He has a gender and a date of birth. So this is Google mapping out these relationships between facts and not necessarily search. So in the book, this is kind of the semantic stack that I use in the book to think about semantics on the web, right? It starts with semantic theories. These are lexical and conceptual. They have to do with rules and logic, theories of meaning, ontology, taxonomy. And those theories are instantiated in semantic technologies, right? Web technologies. So these would be things like metadata, markup languages, knowledge bases and graphs, which I'll talk about in a second, web schemas and ontologies, and semantic software. And then those are reflected in new media products that we use today. So these would be things like public interfaces, right? Intelligent search engine results, virtual assistants, knowledge panels that I was referring to earlier, curated results. These are the types of rich semantic media that I'm referring to that provide us with facts using these technologies. All right, so let me take you kind of really quickly here through these three examples, these three case studies that I discuss in the book, and we'll end with the discussion of disinformation. So back in 2010, Google acquired a company called MetaWeb, which had been developing a large database of facts. And so knowledge graphs are these large databases of facts, and Google, roughly around 2010, got into the fact business, right? So no longer only looking for keywords, but actually trying to provide facts to users. And one of the ways they did this was by purchasing this company, MetaWeb. They also released in 2012 a fairly popular blog post called Introducing the Knowledge Graph, Things, Not Strings, where that former senior vice president of engineering, Amit Singhal, talks about how Google is no longer only a search company that does things like keyword searches on websites, but they're actually also a knowledge company looking to provide facts to people. And it's a really short blog post, but it's been circulated quite a bit because it was around this time that Google changed the name of their search division to the knowledge division, right? So really focusing less on algorithmic strings of text and focusing more on conceptual things like facts about entities. The interesting thing to note is that Google is not the only company that has an internal knowledge base of facts. A knowledge graph is what they call it. Microsoft has one, Facebook has one. In fact, there was a kind of odd paper that was published by researchers at each of these competitors talking about their industry scale knowledge graphs. In it, Microsoft describes how they have a knowledge graph with 55 billion facts, so in the database of their knowledge graph. Google has one with 70 billion assertions. Facebook has one with 500 million assertions, right? So we can see that these are, no longer, these companies are no longer relying only on websites and on Wikipedia. They have their own internal knowledge bases. And so this is really interesting when we think about search and the economy of information sharing today. I'm gonna skip this, but I've tried to do several events focusing on these issues over the years. And one of the questions I've asked myself is how do Google and Microsoft get all of these facts? Where do they come from to populate these knowledge bases that appear in their products? So I'm going to show you two examples of that. The first one is schema.org, which is basically a search engine optimization language. It's a metadata language that web developers and administrators can use to mark up their web pages so that they're intelligently displayed on search engine results. Okay, so this is schema.org. It seems fairly innocuous. It's a very kind of minimal design. And it's actually affiliated with the W3C that I referred to earlier, Berners-Lee's World Wide Web Consortium. So they develop a standardized metadata language that developers can use to add code to their website so they appear in search results. And one interesting kind of factoid about it is that it was started in 2011 as a partnership between Google, Microsoft, Yahoo, and the Russian search engine Yandex, which is, again, kind of odd to see these companies working together on web infrastructure. And that's because they all needed a uniform language that everyone could use to mark up their web pages. Because if everyone's using different languages, there'll be some confusion there. So it's basically structured data for marking up pages in a uniform way. It was a partnership between these large search engines. It's used by millions of websites and applications. And more importantly, for the purposes of your conference here, it is heavily used to verify misinformation and fact checking with structured data, so that news organizations can add metadata that says this has been verified, this has been true, this is fact checked. But it's a little bit of a catch-22 because developers are kind of damned if they do, damned if they don't. If they don't use the metadata markup, then they might not appear in Google's search results, right? Because it's not labeled with this metadata. If they do use it, well, then some of the information from their websites will appear in the search results, and then people won't click through to their actual websites, right? Well, what does that lead to? That leads to loss of traffic, loss of revenue. So it's kind of a sticky situation that these developers are in, whether or not to use schema.org. So I conducted a large study where we did a semantic network analysis of schema.org, looking for just basically like what are the terms that are being developed? What is the conceptual model that schema.org is using to understand the world, right? And one of the things we found is that it's heavily US focused. A lot of the terms focus on the United States. A lot of the terms focus on things like shopping and travel, and not so much on, pro bono legal services or shelters for humans, people who are unhoused. And so there are some sociocultural biases baked into the metadata set there. We can see here on the left, they developed fact-checking terms. So these are terms that journalists can use to label their news stories as being credible or fact-check or as having reviews. And on the right, these were some terms related to COVID-19 that they were developing, so that most of us can probably remember during the pandemic, we would see smart information appear on the Google search results page. And a lot of that was because it was labeled with schema.org metadata. So this is the study that we did. It was published in the Journal of the Association of Information Science and Technology, called One Schema to Rule Them All, How Schema.org Models the World of Search. So Google pulls in a lot of the facts that are represented through schema.org, and that becomes part of their knowledge graph. So that's one way. So I know I'm running out of time, so I'm going to take you quickly through the last example I have here. And I'll just say a couple last things about schema.org. I mentioned that it's used by news organizations. There's a nonprofit organization called Full Fact, which is sponsored by Meta and Facebook, which uses schema.org to, as I said, do things like fact checking. There is the Duke Reporters Lab, which also uses schema.org in a project called the Claim Review Project, where, again, they use a tagging system like schema.org to tag the news stories as being false or credible or misinformation. And we can see that it's being heavily used. More and more people are using schema.org to verify facts. All right, so the last one I'm going to talk briefly here, and then I'll say a couple of final words about disinformation, misinformation. One of the other ways that Google's knowledge graph and these companies get facts, apart from schema.org, so schema.org is all the metadata used on people's web pages, is through something called Wikidata. Wikidata, some of you might have heard, is a sister project to Wikipedia, both run by the Wikimedia Foundation. Wikidata is basically a public knowledge graph. So it's a public database of facts, and it contains 97 million data items that anyone can edit. I'll show you briefly how it's different from Wikipedia. It was launched in 2012 as an open structured database of facts to support Wikipedia, and it contains over 13 billion triples derived from over 190 million entities. Tens of millions of websites use it each day. And if you want to quickly see an example of Wikidata, you can go to a regular Wikipedia page and hit Alt-Shift-G, and you will see a version of the Wikidata. So here's the normal Wikipedia page for Philadelphia, which is where I am right now. And if I hit Alt-Shift-G, I can see it change into the Wikidata page. And you can see that Philadelphia is identified as Q1345. Everything has a Q number in Wikidata. We can also see that it's linked to Google's knowledge graph, Google Maps, Google News, Google Arts and Culture. And if you go to Google Arts and Culture, there's lots of information that's populated from Wikidata listed there. So this is how Wikidata information is organized. You can see that it doesn't have natural language. It's mostly just facts, semantic triples. So-and-so was educated here, was born on this day. It doesn't have natural language. It's just a database of facts. So we did, like schema.org, we wanted to do a study to see how are these facts organized on Wikidata. And so we did a large study where we wanted to see the ontology. How are these facts organized? And so this is the upper level ontological structure of the Wikidata base. You can see it's very abstract at a high level, talking about parts and properties and classes. But as you drill down, there's really interesting terminology that's used that can be affixed to all of these entities in the graph. Terms like pricelessness, greatness, acceptability, bad. All of these terms are used to tag entities in the knowledge base. And we know that it's used in Google because if you look for a word like greatness on Google, the knowledge panel on the right-hand side, if you click on the source, it says this content comes from the knowledge graph, but the language is identical to the language that's on the Wikidata. We can also look in Wikidata for things like, what artists or authors have works that are described as notable. Well, there are some, just like schema.org, there are some interesting sociocultural biases. For example, mostly American and British authors have works that are described as notable, then maybe Russian and Japanese, but not so much others. So we can see that there's a little sociocultural biases there. I have many other examples, but I won't use those right now. The last thing I'll say about Wikidata is that a lot of these facts that are inside of it are not referenced to sources. We all know that Wikipedia, usually at the bottom, there's a list of sources where the facts come from. Wikidata does not have this. There are many, many facts that are not sourced, and Wikidata has a different copyright license than Wikipedia. With Wikipedia, search engines need to say where they got the information from. Wikidata does not have that type of copyright structure, and all of the facts are freely available for companies to use without citing or sourcing Wikidata. And that's a very different relationship to information. If you want to read more, we published an article called Wikidata as Semantic Infrastructure, Knowledge Representation, Data Labor, and Truth in a More Than Technical Project in Social Media and Society. Okay, I know I've got maybe one more minute, so I'm kind of saving the most relevant bit for last. How is this all related to disinformation, the theme of this conference? Well, I'm going to give you some examples. Some of you may have seen news stories popping up recently. Here's one. Siri says that the national anthem of Bulgaria is the Latin hit Despacito. We know that the national anthem of Bulgaria is not Despacito, it is Mila Rodino. One of the reasons that Siri was saying that is that the metadata in Wikidata, someone labeled it incorrectly. They wanted to play a joke or screw around and put disinformation. And that misinformation was pumped out briefly before it was fixed onto products. Well, you might have seen articles like this one where a New York Times reporter said, Google thinks I'm dead because her name was Rachel Abrams. And in the Google knowledge graph, the knowledge graph got confused because there was a popular author who died named Rachel Abrams. And the knowledge graph confused her image with the death of this author. So two different people with the same name, and that's being confused. And so she wrote an article about how difficult it was to say that I'm not dead, Google. Another one, which I won't go into detail because I know I'm out of time, is Donald Trump on Bing. If you look at the knowledge graph, a lot of those facts come from really questionable sources. One of them is Medium, which anyone can publish on. And if you click on the author who published some of these facts about Donald Trump, they lead to articles like how to disguise extraterrestrials as humanoids, and is Bigfoot real or fake? This is where the information is coming from that's being shown to millions of people as someone who writes about UFOs and Bigfoot. And nowhere does it talk about Donald Trump's conspiracy theories and things like this. If you search for things like Sky, you get information about the telecommunications company, Chinook, nothing about indigenous Americans, about military aircraft. And Kafka, you see information about big data software, not the author, which I think is a very Kafkaesque scenario to be in. The last example I'll show you is one I start my book with. My parents are from a Greek Macedonian village called Aramensko. And if you type Aramensko in Google, Google changes the results to Alona, which is the Greek name of the village. And we know this because if you look at the Wikidata, there's a Greek Alona entity, and it says it's also known as Aramensko. So Google's changing the name of a mostly Slavic Macedonian village to its official Greek name, even though most people would consider it Macedonian. You can see this photograph that's used here calls it Aramensko, the Macedonian name instead of the Greek name. So I'll just leave you, this is my last slide, that there's 5 theses that I talk about in the book, and they are that semantic media are leading us to a world where verifiability is eliminated. It's hard to verify facts coming from Google if they're not referenced. Meaning is monopolized by these companies. We don't have these individual sources. They exploit social data. They introduce new gatekeepers to facts and knowledge. And obviously, there's a relationship to misinformation and disinformation. All right, I know I went a bit over time. Thank you very much. Please check out my book, Semantic Media. Thank you.
Thank you. Can you hear me?
I can hear you, yes.
Yes. Thank you very much, Dr. Iliadis, for participation and for your contribution. And we hope to welcome in Istanbul next time, our next symposium. Do you have any questions, dear guest? No questions. Okay. And would you like to say something more?
No, just thank you for having me. And I know it was a lot, but please check out the book if you're interested in any of these topics.
Okay. Thank you very much. Now we sent you off now. Bye bye. Thank you again.